technology and engineering education, you cannot do much better. IIT and MIT. And then 15 years ago, joined Qualcomm. Today, he is Senior Vice President of Engineering at Qualcomm Research. He leads all the research of the Qualcomm, not only within the US, which is San Diego, California, but also at the international level, which is Austria. There are so many I can't memorize it. I'm going to read it. Austria, China, Germany, India, and Korea. And he has 15 patents. Let's welcome Dr. Rajesh.
Thank you, Mohan. Thank you very much for inviting me here to talk about the future of wireless. Now, one of the jokes that I have when I sit with my colleagues, if there is a talk that says future of anything, we whisper to each other, now we know what it will not be, right? Whatever we say future is going to be, future has a way of being something different from whatever we thought. But we have to put a stake in the ground. We have to say, this is what we think we need to go towards, and then see what happens. So I'm going to give you Qualcomm's perspective. And Qualcomm is a wireless company, so it's going to be wireless perspective. And within wireless also, Qualcomm is more focused on cellular, so it's going to be more cellular-oriented perspective. Okay? And I will start with something that we have been talking about for a while, and then I'll go towards things that we want to go towards, that we think is going to happen in the future. So a few things. I don't need to tell you guys that mobile, these phone devices that we all carry in our pockets now, is the biggest platform that has ever happened in history. Pretty much there is one phone for everybody, every man, woman, and child on the planet. Amazing to think about that. And now, we also need to remember that the last generation of technology that we talk about, 4G, that is already there, was thought about before iPhone came. And there is, of course, the mobile, the devices after iPhone versus before iPhone. There's a big difference between the two. Okay? People started thinking about 4G before that. But now, with the new smartphone, people are thinking about Internet of Everything. They are trying to do all sorts of things on it. Basically, every other device that you used to carry, you stop carrying them. You just carry your phone. Okay? So we need to think about what does the connectivity for that looks like in the future. There are a few things that we have been talking about at Qualcomm for the last couple of years, and I will give you a little bit of update on some of those before I go on to what we call 5G. Okay? And again, 5G at this point is a bunch of ideas that have come together, and they have probably become much more harmonized over the last few months, maybe a year or so, than they were before. But I'll give you my spin on that. So on the very beginning, the first thing that we talk about here is more data. Of course, everybody wants more data. As Alicia talked about video, then we said, well, what about 4K video? Well, that's exactly what's going to happen. Anytime we give people data, they're going to use more of it. So this is something that we have been talking about 3 years or so, that the data demand is going to go up by 1,000 times, 1,000x, whatever it was. So in 2010 to 2020, we said it's going to go up by 1,000x. And many people have said, well, maybe not. The growth is not quite that much. In the end, it comes down to if you can deliver data, say 1,000 times more data to people at the same price, then of course people will take it. If you're going to charge them $35,000 as opposed to $35, then of course they don't want it. So that's obvious, right? More things are going to be connected, more devices, not just smartphones, but other types of devices. And of course, people will want more richer content, 4K video, and there's going to be more of different types going in the future. So let's talk about 1,000x a little bit. And we started talking about 1,000x a few years ago. And at that time, we said that 1,000x is primarily going to happen in two different axes. There's going to be more spectrum needed, and there's going to be more small cells, much denser networks. Okay? And there are other things that you can do also, and we have communications experts here, and they know how to take advantage of the channel as best as they can, and so bits per second per hertz keeps going up. But we felt that to get to 1000x, you're not going to get there by simply improving the efficiency of the channel. You're going to have to use more spectrum. You're going to have more small cells. And at that time, when we talked about spectrum, we weren't talking about millimeter wave, but since then that has changed quite a bit. This was a few years ago when we started talking about it. But let's just first talk about, I wanted to give you an update on what we have been able to do with 1000x. So let's talk about the density of the network first. So high density network, long time ago, people wanted to cover the entire world using satellites. And then they realized that satellites was not enough. You really wanted to have terrestrial network because the number of cells that you can put on the ground is a lot more than the number of satellites you can put up there. And people always want more data. And so now this goes to another level. The big dome over here is the big cell, big tower, okay? And so that is still going to provide you with the underlying coverage. Everybody needs to have connection to that. But then underneath that, there are a whole bunch of small cells. And these small cells could be either deployed by the users. They are putting these small cells in their homes. Or they are deployed by the carriers, or they're deployed by enterprise, all of these different ways. And really, the amount of management that you can do is going to be different. If it's deployed by somebody, if AT&T just ships a box to me and says, plug it into your home DSL or home cable network, the amount of management that can be done is different compared to what can be done if they roll a truck and put a small cell somewhere. But all of these things need to get together to get to the 1000x number that we are talking about. And a couple of years ago when we first started talking about it, most people said, well, don't know if it makes sense because this will never work together. You can never have these small cells that, different apartments in the same building may have small cells pointing towards each other. There will be interference and so on. So I wanted to give you an update on that. About a year ago, we did a demo. And this demo was in one of the NASCAR locations. And our belief was that if it could work there, it will work everywhere. And here's the reason. When we talk about small cells, we typically take advantage of the fact that while most of the towers are outdoors, most of the people are indoors, and most of the data demand, therefore, is indoors. So somehow, if you can take advantage of the infrastructure that's already available indoors, then that'll be great. But indoors also gives you one more thing. Here's a hall, and there are walls. And maybe these walls don't have a lot of attenuation, but a lot of walls have more attenuation, so somehow you get isolated. So if you put a cell here, then it's not going to interfere very much with the cell that's next door, and you get some sort of isolation. That's great. In NASCAR scenario, it wasn't the case. It was all open, and there were trucks coming and going and moving, and I'll point to this thing over here. I should make sure that I press the right thing. Okay, I don't know if I can get this thing to work as a laser pointer. Let me just, sorry, that's what I was afraid of. Okay, let's go back to this. So there's a map on the left-hand side that you can see. Those dark gray things are trucks. And you can see those triangle things. Those triangle things are the little small cells. And there's a picture also over there with trucks sitting there, and the distance like 7 meters there. Some cases the distance was even lower. And of course, we believe that this was the densest LTE outdoor networks ever put together. The density was roughly equivalent to 1,000 per kilometer square. That's the kind of density we were talking about. It was about 1/30th square kilometer, and there were 30 of these small cells there. The capacity that we were able to get out of the system was 40x compared to what you can do from a cow or something like that. And I don't think anybody will be surprised that the capacity was high. What will be surprising, what we really tried to show, that you could actually have seamless coverage. You will not have pilot pollution so that when you try to go from one small cell's coverage to the other, it will drop your call. And that is done by ultrasound. That's something that we developed, so that you can put these cells in an unplanned way, put them wherever you think is appropriate, and these cells will not necessarily try to all go to the highest capacity that they can. They will reduce their power automatically, depending upon what the radio scenario is, to make sure that the handoffs are not taking too frequently, there are no dead zones and things like that. And that's really what we were trying to show. Of course, our marketing group always goes out and talks about how many bits per second they can push through, because that's what most people understand. But really what we're trying to get to is to make sure the coverage is seamless, and you can walk around in that area. It will not drop a call or a connection. One other interesting thing there was that people said, oh, there will be big trucks that will come in on the race day, and suddenly your coverage will be worse. Of course, that's not the case. When you have the big trucks come in, that creates isolation between one small cell and the other, and suddenly your throughput was actually higher. More bits per second you can get through. That was exactly the thing that we wanted to see, and that's what happened. So that's an update that I wanted to give you guys. The second thing that that I talked about in 1000x was this spectrum, right? We need more spectrum. And of course, when we first started talking about it, we were talking about licensed spectrum. But then we said, well, we don't have to limit ourselves to licensed spectrum. There is unlicensed spectrum at the other end, and unlicensed spectrum is primarily used for Wi-Fi, for local area networks. And Wi-Fi is a really nicely designed system for local area connectivity, but it doesn't play that well with wide area network, with cellular system, okay? So the question was, can we come up with a variation of LTE that can work on this unlicensed spectrum, and I'll give you a little bit of update on that also. And in the middle, there is the shared licensed spectrum where some incumbent is already there. Maybe it's a government spectrum, and there was a lot of discussion on that. And we tried to figure out how we can use it, and we did some demo with Department of Defense to show them that if we try to use Navy spectrum, we will not interfere with them, and they will not interfere with us so much that it will be a problem. Okay, they're very scared of the situation that they allow some civilians to use their spectrum, and then they start to take it back according to the agreement that they had before, but suddenly people who are using it start complaining, and then they have to have problems. But anyway, we were able to calm some of their doubts. Well, just talk about the LTE advance on unlicensed spectrum a little bit. The reason it works well is, and we have done a lot of trials on that in our system and on campus in San Diego, and it's going through standards and various other through the industry right now. Basically, the way it works is that you use the licensed spectrum as the control for the unlicensed spectrum. Okay, so that way you know that the reliability of the network is there, but then you use the unlicensed spectrum to use for data transportation whenever that is available. Of course, unlicensed spectrum is also being used for other things, for example, Wi-Fi, so we had to put in certain things to make sure that it coexists with Wi-Fi. And one of the advantages that it has is that this way, the unlicensed part of the spectrum is also used by the same network that's using the licensed spectrum, and the whole unified network works much better. Okay, so this was the update on 1000x. I want to talk about what happens after that, okay? So we started thinking about 1000x when we're talking about, okay, what will things look like in the next few years? People need more data. There will be more and more of everything that people want to use, and they want to use it at low cost. You can't increase people's monthly bill by 1,000 times to get 1000x data. Well, what will things look like in 2025? And I can only tell you that no matter what I say here, again, I'll be wrong. And the reason I say that is because about 10 years ago, I remember going to my boss's office and said, let's talk about how things will look like, how phones will look like in 10 years, okay? And this was 2004 or so it's 2014 now. And we talked about how much storage will be in the phone, what is the data capacity of the phone, how much battery life there will be, how big will be the screen. And we thought that we were being very, forward-looking, and we could, put big numbers there. And of course, it turns out that we were short in every single aspect, okay? We thought that the storage will be maybe a gigabyte. That would be amazing to have. 10 years ago, that seemed like a very large number. Now, of course, you don't think anything of having 20 times that much storage in or 60 times that much storage in your phone. And same thing in everything. So we don't know what things will look like. But now if you think about what we want to do with this, do with our network, then of course you think about, well, humans will be connected. There are things and machines, they will be connected. There will be cars, there will be drones, there will be medical devices. And let me tell you a little bit about why. I'll get to that in a minute. Let's just talk about a few things here. So that's where I talk about 5G, okay? 5G to us is not just something that increases the bit rate. It has to increase the bit rate, but that's not the only thing that it does, okay? It's not something that simply gives us higher capacity network. Of course, it has to give us higher capacity network, but it has to do more than that. And so at a very high level, say, okay, it has to be able to do all of those things, but it has to enable new services and devices, okay? And then we have to think about what those new services and devices are. and it has to allow for new experiences. And again, we have to think about what those new experiences are. So let's talk about that for a second. So scalability and adaptability. Okay, we need to make sure that whatever network we come up with has to be scalable and adaptable. And the reason we have to think about that is for the same reason that Alicia was talking about here for cloud computing, right? You want to have a network that can support a lot of these different services so that somebody who wants to offer a particular service doesn't have to go build his own network. That'll be too expensive. You want to do this, so you want to include that in your network. And so that's what I mean by unified platform here. Revolutionary design, and we'll talk about that in a minute as to what are the different things that we want. So before we talk about that, let's talk about what are the different use cases that could possibly drive it. And again, this is something that we are thinking about, and I'm sure that there are lots of different uses that people will put this network to that we have not thought about yet. But let's just think about that. So on the very left bottom side over there, that's mobile broadband. This is the traditional thing. People want more bit rate, more capacity. I have a picture of a stadium there to sort of indicate that that's one of the most challenging situations that we face, that everybody goes to Chargers game in San Diego and suddenly your cellular system doesn't work, your Wi-Fi doesn't work. And I took a tour of the new 49ers stadium, and I was told that that is one of the best. And actually, when I went there, there wasn't a game going, so the network looks amazing there, but still I hear complaints that people say, oh, the Wi-Fi doesn't quite work. Anyway, it's much better than what it was before, but that is a challenging situation. You do want to have the ability to download lots of data, lots of people using it at the same time. That has to happen, okay? No doubt about that. But then what happens beyond that? So there is this thing on the top right, we're talking about proximal and aware services. And this is something that happens when you go to a stadium also. There are things that are happening around you, and you want to know what those things are. Okay? You may have your friends there, you may have services there that you want to know where those are, and you want to take advantage of those. Right? You could simply send your GPS location to the cloud and get them to tell you, what things are nearby. Maybe that is the most efficient way, but at least we are thinking about how to do that in a peer-to-peer manner. Can you discover who is around you in a peer-to-peer manner? Another way to think about that, and this is, I don't have an August lock, but some of you may. A lot of my colleagues have this August lock. This is a new lock that people use, which is basically it's electronically controlled. So you walk up to it, and if it's the right phone, then it unlocks the door. Okay? And if it's not, then it will not. Now, it's great as an idea, and that sort of also gets to thinking about what we are used to now with our phones these days. What you want to do is that when you walk up to the door, it should sort of know that you are there and it should turn on. But it doesn't quite happen that way. And the reason it doesn't happen that way is, of course, my phone is given to me by my company, which says that for security reasons, you have to put in a four-digit code. And by the time I put in four-digit code, if I'm already carrying my groceries or whatever, well, I'm already right next to the door. If I'm already right next to the door, then somehow the utility of having a remote-controlled door is minimized. It's not quite as good as it was. If I could get from my car, I could do something, and it could actually, without me having to press a button, it should discover that I'm near the door now, and I'm the right person, and hence it should open. So that's something when I talk about in proximal and aware service. On the left top, I talk about the massive number of things, because as we have realized, once we start using our phones for everything, we really do start using it for everything. We wanted to control our houses. We wanted to control everything. And then on the right-hand bottom side, we have mission-critical services. People are talking about connected cars, and these cars need to make sure that they are working in a safe manner. But people are also talking about healthcare remotely. So you start with remote monitoring. Somebody is allowed to leave the hospital a little early because the doctors can now monitor them remotely. But then going forward, can you do surgery remotely? Well, I certainly would not trust the current network to get a doctor to do surgery on a patient, but maybe in the future we will. Okay? But the question is, again, can we have a network that can support all of those things and still deliver the mobile broadband experience that we are used to, whether it's 4K video or 8K video in the future, or whatever that number happens to be. Okay? So what that means is that if you look at what the network needs to design for, it has to have multiple dimensions of extremities. Okay? On the, again, bottom left-hand side, I'm talking about simply extreme broadband, our normal thing that we are used to, and awareness, in the sense what is proximal to you. But then if we talk about massive number of things, large number of things are connected, not all of those things need the same level of service. Some of those things need to be very low cost. Some of these need to be very low power, but their mobility requirement may be much less. Okay? Can we have a network that can somehow accommodate that on the one hand, but on the other hand, when we talk about mission critical services, at that point it can expend your power, but then be very, very reliable and very high, and go through mobility situations without any outages. Okay? And so this is a very diverse set of requirements that we want to put on the network, and that makes it very challenging. It's a little easier to say that, okay, I just want to add more bits per second. That's easier to do compared to what we are talking about here. So if I then think about how to design a network for that, I said that, well, we do need to have somewhat of a clean slate design. Now, I will tell you that in my research group, I have a project that is trying to work on advancing 4G, and I have a project that's trying to work on 5G. And every time people who work on 5G come up with something, hey, I have this design for a very low latency channel that will be very highly reliable, the 4G guys come back and say, hey, I can do that too. So I don't know exactly whether it will be an LTE-based system or it will be a new system, but there is something that tells me that when you start adding new functionalities to an old network, at some point starts to break. Okay? And so that's why you have to think in terms of, well, what will a clean slate design look like? And so we are, of course, looking at both of them. Can you add this functionality to LTE? Can you add a very low latency channel to LTE? Can you add a much higher security to LTE and so on? But nonetheless, we are also looking at the whole new air interface in order to try to do this thing. The notion of simultaneous connectivity has to be there because no new network ever gets deployed everywhere all at once, right? You put this thing in one place, and so you want to make sure that 4G and 5G work together. And then at the very bottom left, I talk about user-centric here because the network has to be able to deliver the services that are needed by that specific user. And in this particular case, the user is not necessarily just the person, not just the human, but possibly a device or a machine or something like that. And different devices, different users will have different requirements, and you do have to make sure that those requirements are met at the cost point that is appropriate for that particular service. And so this is making the same point that I just made, that when we started 4G, and then after that we started to add a lot of new things to it. We said, okay, let's just make sure that it has broadcast capability. It has the capability to broadcast the same information to a bunch of people at high efficiency. And then maybe we can add operation unlicensed spectrum. Maybe we can add ICIC. This is the way that small cell and big cell live together. Maybe we should have device-to-device communication. All of these things we start to add, and that all works fine. But at some point, it starts to break down. So that's why we think about, well, can we start to think about a new network, a new 5G network that empowered new services, has scalable network architecture so that it can provide these services for those things that are very low power, possibly low mobility, and on the other side, very high mobility, and also very high reliability requirements, all of those things. Okay? And in all of those different dimensions, it must scale. Talking about spectrum again, whatever network we come up with has to have the ability, or has to be designed from the scratch to cover all of these different types of spectrum. So in one dimension, we are talking about licensing or licensed nature of spectrum. It has to be able to handle licensed spectrum, unlicensed spectrum, and shared licensed spectrum. In the other dimension, you want to use below 1 gigahertz for very high penetration, very high link budget, between 1 and 6, which is more normal that we use, but also going above millimeter waves and so on. Again, I'll talk a little bit about that. Of course, in the context of 5G, millimeter waves have been talked about a lot, so that's of course, that will be a component of it. We just don't want to think that that's the only thing we want to do. We want to do all of those things that I just talked about. So again, as I mentioned, no matter what we do, we are not going to be able to deploy a whole new network everywhere all at once. So our operators, they have to be able to deploy these things in a piecemeal manner. And whatever new things they put in 5G, whether it's above 6 gigahertz, the millimeter wave part of it, or below 6 gigahertz, that all has to work nicely with the existing 4G network. Okay, so and I'll talk a little bit about networks in a minute. But our devices will have to be multi-mode, and which of course makes us as Qualcomm, which is we make device chips, very happy, because the more multi-mode it is, the more complexity it is, you would want more of our newer products. So that's always great. But you want to have the network which can play well with 4G, and then add 5G new services as operators start to deploy these things. Millimeter wave specifically I wanted to talk about because it is actually quite exciting for us. Obviously, it offers the largest bandwidth available. There is no, I mean, you can't have 500 megahertz at 700 megahertz. That's just not possible. You have to go at much higher frequency. So you go there, and in order to overcome some of the challenges, for example, the propagation and penetration losses, you have to do something different. You have to make sure that the beams are narrow so that you can go longer distance. You do much more spatial reuse, which of course is a blessing, not just a curse, because if your signal doesn't go very far, you can put a base station here, you can base station not too far away, and they will not interfere with each other. So that's great. And of course, one of the things that we've been able to do with millimeter wave before has been backhaul. So now when we talk about dense networks, we want to use this millimeter wave both for backhaul and for access. And of course, for backhaul, it has been used for a long period of time, but now we want to take advantage of it. Actually, one of the best things that we are thinking about is that how to use the same spectrum, whether it's above millimeter wave or below 6 gigahertz, for both backhaul and access, because that's one of the problems that we always run into when we talk about densifying the networks. And so we want to have a network design that is thought from the very beginning that the backhaul and access can be put in the same spectrum, and I'll give you a little pictorial representation of that in a minute. One of the things that I think Ted I saw earlier, he talks about a lot that, yeah, you have in millimeter wave, you have the problem that a particular path that a particular signal that you're tracking suddenly disappears because of some reason, but then the same signal reflected off of something else can actually come to you. So if you have the right ability to search for that signal all around, and then you should be able to find it pretty quickly. Now, it will still not be 100% reliable. There will be places where you will have outages, and that's why if you look at all of my pictures, I always talk about make sure that there is some underlying ubiquitous coverage that's always there, and then take advantage of these millimeter waves whenever you can, because that gives you the very high bandwidth that you're really looking for. Again, when we talk about deployment of this, the 4G and 5G, you will not just do 4G here and 5G here, but you will have carrier aggregation across them. So that will be an obvious thing that we'd want to use. Let's talk about networks a little bit, and I'm not going to spend a lot of time. But on the left-hand side, I talked about multi-access. Of course, you're going to use all the different frequencies that are there. You're going to use all the technologies that are there, and you're going to make sure that you have the same network that controls everything. One thing that we always sort of joke about, that I use my phone everywhere, and then, most of the places where I go, the Wi-Fi signals are already, I have the password already in my phone, so it goes through back and forth pretty seamlessly. Then I come to a hotel here, and I can't use it seamlessly because I have to go in and push in some password. Okay? We have to be able to do better than that. We have to have a way that the network can control all of those things in such a way that you don't have to go in and put in password. Almost everybody in this room does not have a problem with something like that, but my wife is not a techie person. Okay, so whenever she goes somewhere, she actually calls me and says, so how do I do this thing? How do I use my phone, switch it from this mode to that mode? Because I always tell her, if you go to a foreign country, don't try to use your phone in a normal mode because it'll be too expensive. I said, how do I do it? Normal people have to be able to use this thing without the techie knowledge that we have here. So that's on the one side. On the other side, the network, one size does not fit all, as I was saying. There are some things, there's some devices that don't need the mobility that is already designed in our cellular network. The cellular network is designed really well to make sure that as you're moving around, your whole subscription, everything works beautifully, which is wonderful, except you don't need it for everything. If you don't need it for everything, then make sure that you can reduce the cost for those things that don't need those services. So that's an important thing. One other thing that came about as we talked about it, in our discussions, is that if I go into somebody's home, I want somehow to be able to, for this person, to be able to offer a local network there. And, and maybe it's not that important when you go to somebody's, your friend's house, they can just give you your Wi-Fi password and that's fine. Or maybe, some simple thing can happen. But one of our executives at Qualcomm holds a fundraiser on a regular basis for a number of causes in San Diego. And so he invites a large number of people to his home, and of course he has a large home, so that's great. But when you go over there, then suddenly people's phones don't work anymore, okay? Because he lives in a somewhat isolated area, so the coverage is not that great. And he doesn't want to give out his Wi-Fi password over there because there are too many people and he doesn't know everybody. It would be nice if he can easily provision a network which is basically going back to the same carriers. It's going through the carrier's network, but it's somehow using small cells that he has installed in his home that works seamlessly for these people as they come in. They have some sort of authentication, and once they have that, they can use it. How do we do that? And that's something that we really think is kind of important. That I, as not as a carrier, but I, as somebody who is a normal person, can offer a service to somebody by leasing capacity on a short-term basis from somebody who has the capacity, like a carrier. So again, reiterating the same thing that I talked about before, we will have these networks that will have users of different types, and the users will have different needs, and we need to make sure that those needs are met in 5G. Something that we sometimes call edgeless connectivity. So one possible example of that is that you have a cell tower, that's the one in the middle, and then it's offering service to an area. Some areas are not easily accessible, so then you may have a backhaul or a relay or some sort of a device in the middle that's actually relaying this information. Okay, so that's one way that the devices that were supposed to be just a device is now actually being part of the network. Another similar situation would be that I have a phone that is actually controlling a lot of devices that are on my body or near me. So that's another way that that a device that's traditionally thought of as a device that talks to a base station is also offering service around it. And similarly, you can have a number of devices that are all peers that can somehow get together in a mesh network. So all of these things, we want to be enabling these things in the 5G network. If we can do all of those things, we feel that we will truly be able to achieve the edgeless connectivity that we talk about. That will lead us to 5G networks that will offer the uniform broadband fiber-like coverage to everybody. This is the stadium scenario that I was talking about. It can offer support for mission-critical services like remote surgery, and it can connect everything from small sensors to very complex robots. And complex robots are of interest to us. There are cars people are talking about autonomous cars, but people are also talking about drones these days. And drones are becoming a little bit of a problem. The UAVs, they're flying around, and the pilots are sometimes complaining. But they could be much more useful if they are actually connected to the network, and then perhaps there are some regulations that you place on them that once you go out of connection, or once they can't connect, or if they do something that is not quite right, then somebody, a FAA type thing, can control them and ask them to land. Again, for all of those things, you need mission-critical connectivity, and we believe that 5G can get us there. And hopefully, if all of these things come true, then that will change the way we use the network. We use wireless, we use internet, all of that will change, and that will truly be a unified network for the next decade. Well, thank you very much.
Very sweeping and ambitious vision. We expect nothing less from Qualcomm. I'm sure those will solicit many questions from the audience, so we'll have time for a few. Brian Modoff, as usual, has one.
Yeah, can you talk about how you envision 5G from an air interface standpoint? When you're hopping across multiple frequencies, you're going from 1 gigahertz or below 1 gigahertz all the way to 60. Do you imagine the air interface being constant across that, kind of like what you're looking at with LTE unlicensed? Do you imagine having to optimize it based on the frequencies you're dealing with? And then what about backward compatibility to 3G? You talked about 4G, but what about back to 3G for guys like AT&T who may still be running 3G networks in 2025 and need that support? Thank you.
Thanks, Brian. You always have on here? Can I turn off? OK. Thanks, Brian. Great question. The vision is that we should have a design for the waveform that should be scalable across all of these spectrum, whether it's 1 gigahertz, 6 gigahertz, or millimeter wave. Okay? Now, there are challenges with that. Okay? It's not easy because something that makes sense in one case doesn't make sense in the other case. And that's why it's a work in progress. So I can't say that that's where we will get there, but that's the vision. That's where we want to get. Your question about 3G versus 4G versus 5G, backward compatibility is a funny word in some sense. Okay? You can put backward compatibility by having complexity in certain devices and sort of hiding that complexity somewhere. And in some sense, we feel that we are up to the challenge. And in Qualcomm, we have done backward compatibility that way in previous generations by simply making sure that in our little chip, we put all the different modems that are needed to connect to the network, and we'll probably use that if we can't integrate them in the network in a seamless manner. I can't quite tell you with confidence exactly what the answer is going to be, but the vision is as follows. We want to have as many things integrated in a seamless manner as possible. What can't be done, we'll just make sure that the modem for that is actually in the chip so that you can switch to that mode, and at least backward compatibility is achieved in that way. Hopefully that answers your question.
With devices getting smaller and smaller, more portable, and the Internet of Things, would you say that it's the size or the power limitations that are going to be one of the major limiting factors towards pushing 5G and size in terms of antennas, or power just in terms of consumption on small things that don't really have much battery life?
So things are not just getting smaller. They are getting smaller. Some things are getting smaller. Some things are getting bigger. Things are moving in different dimensions. So whether size or power is going to be more important, I think I'll say yes. But basically, both of those things are going to be important. There are certain devices for which size is going to be critical, okay? And there are certain devices for which power is going to be critical. There is just no doubt about it. For example, in wearable space, I think at this point, the kind of wearable devices people are talking about, power has become critical, okay? But on the other hand, in some sense, the reason people are not talking about size is perhaps the size is good enough for now. But there are going to be evolution on that also when you start to put medical sensor on your body, when you're starting to put everything in a pill, and you're going to ingest that part is going to be important too. So that's one of the reasons why if you look at some of the pictures that I was showing, there are multiple dimensions. Things are going to move in all these different dimensions. There are things that are where the size is going to be the biggest problem, that the antenna size is going to be only that small, and something where the power is going to be problematic, and some things where neither of those two are problems, and well, they're a problem, but they are not the thing that are putting the biggest constraint on your system. But the fact that you want to transport 4K video, as somebody talked about, is going to be the biggest challenge. So I think all of those challenges are going to exist, and I think the main message that I wanted to get across in this talk was that we want to have a network that can support all of those different requirements. Hopefully that answers your question.
All right, I'm sure there's many, many more questions. Unfortunately, we don't have time to take them here. However, Rajesh and Alicia not only have taken time out of their schedules to come speak to us, they're going to stay afterwards and will be next door in the Tech Theater to talk with all of you and answer additional questions. So I encourage you all that have questions or would like to talk to them more about their talks to visit them next door after these keynotes are over. So I'd like to present Rajesh with a plaque, a token of our appreciation for coming here from San Diego. We appreciate it.
Thank you, Jeff.
Thanks again. Great talk. Okay, so now I'd like to change gears slightly and recognize the Best Paper Awards for GlowComm 2014. So if I could have those yes. So we did things a bit differently.